guys, so let's continue with our chapter 8 reactions. Next reaction I'd like to take a look at with you guys is acid catalyzed hydration. This one's a pretty simple reaction too. Similar kind of steps to some of the reactions that we saw where carbocations and radicals formed. So the reaction involves an alkene, which again is your nucleophile. Right, and we're going to use sulfuric acid and alcohol here. So note here that this mechanism is the reverse mechanism of the dehydration of an alcohol. Well, we saw that in our chapter 7 lecture notes. Now, if you recall, dehydration required concentrated sulfuric acid. Right, so concentrated sulfuric acid or phosphoric drives the equilibrium to form the alkene. So here we want to use excess water or alcohol to drive the equilibrium to the alcohol. It's the hydration product that we're going to see here. So we don't see little brackets around this. We see dilute H2SO4. Right, and just again as a reminder, we mentioned this just below, but this is the reverse reaction of dehydration. Okay, so if we use an alcohol, ROH, then we end up forming an OR group there. And an OR group gives us an ether. So if we use ROH, right, so CH3OH, so on and so forth, what we get is an ether. And the nice thing about that is this is a reaction in chapter 14 where we talk about ethers. So it's ROH or H2O. So then if we use H2O, get that out of the way, what you get is an alcohol. And the mechanism's the same though for both of these. Now, the stereochemistry, carbocation forms with possibility of racemization, right? And regiochemistry is Markovnikov. And again, not something that you have to memorize. If you know the mechanism, then it kind of just makes sense. So let's take a look-see here at the mechanism. So why don't we pick something that could give us interesting products. So let's pick this guy, and then reversible reaction. So we're using dilute H2SO4, and then dilute H2SO4, it's dilute with water, right? So it's aqueous. So we have H3O plus present. And this is step number 1. Now, remember, this is your nucleophile. So the first step of this reaction is we're going to come over and we're going to grab an H. Okay. So that H is going to go to the position that generates the most stable intermediate. Right? So there was already one H that was right there. So there's your second H. That's Markovnikov. Gots more, gets more, rich get richer. And a plus charge right here. So I will mention something here, is that we have a carbocation, so you need to watch for potential carbocation rearrangements. So that's similar to stuff that we saw with SN1, right? Reactions, NE1. All right, so that's step number 1. So step number 2, we're using water, right? Dilute H2SO4. So this is our step number 2. We'll put in here H2O. So at this point in time, this is really just an SN1. So right, we're coming around here. And remember that carbon with a plus charge right there, that carbon right here is sp2, right? So recall that's your carbon with your p orbital. So the water can go here and water can go there. And that has the potential to lead to different stereoisomers. In this case, it won't, because these groups are identical. So to have a stereocenter, remember you have to have 4 different groups. 1, 2, 3, 4, and the rest should be fairly straightforward. So water's coming in. That's going to grab a hold of that H. So you form H3O plus there. In this case, you get your alcohol. Okay. So let's look at another little example just to kind of see what are some other possibilities. So let's do example number 2 down here. And let's take a look at this guy. So same thing, we'll use dilute sulfuric acid, right? Sometimes you'll see that as H3O plus also. We got this here. Okay, so analyzing this problem, we know that this is going to happen. That's the first step of this reaction. All right, so when we do that, we end up forming, right, our CH2, gets the H. So I'm just drawing that out for clarity. And we get a plus charge right here. Okay? Now, there's an H that's over here. So we could get an H shift. Right? So let's just redraw this thing down below for a second with its H here, and a plus charge there. Right, and I'll just do this. How about dot, 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 dot. And let's do H shift. So the H shift, remember that the H atom, along with the set of electrons, moves over to the adjacent carbocation. So that'll give you this. All right, so basically, this is going to lead to products, and this guy to some extent too. So if we're trying to be real inclusive of everything, water comes in, right? Water attacks both of those spots. So you got H2O, right, coming around here, doing this. And then remember, we can do the front and the back P lobe here, right? So what that would give us is this guy, right? Plus that guy. And those are H's, so let you guys catch up a little bit there. Right. Now, what happens next is our last step. So we do a deprotonation, right? So water comes over here, right? And water will grab a hold of this, right? And then I'll just use different color arrow down here. Right, so when it does that, it leaves us with 2 products. So you get this guy plus that, right? So I've kind of run out of space down here below, but right, we know water attacks here, right? And then we lose an H, so I'll try to fit that all in. So water coming in. I have to write real small down here, so sorry. Gives you this guy, right? And then last step here. Does that, right? So again, let me let you catch up there. But the other product that we get there would be this guy.